Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today we've got another customer requested topic. Here it is. Add a Garmin GPS to your control system. Well, this isn't the first time we've added a GPS to a Horner OCS on this channel. We've shown you before how to do that with a banner unit. That unit interfaces using Modbus. Today, though, we're going to show you how to interface with a different type of interface with GPS, and that is something called NMEA 0183. It's kind of a standardized GPS protocol that's been around an awfully long time, and it's supported by the OCS. So we're going to show you how to interface that today. So without further ado, let's break down the topic. We're going to start by introducing the Garmin GPS receiver and then talk about some of the different applications in which you can use it with the Horner OCS. We're going to talk about how it interfaces, that NMEA 0183 protocol we talked about before. Well, don't worry, we're not going to go into all the details of the protocol, but we're going to go through, how the interface actually connects to the OCS. We'll give you the details on what GPS data is provided by the unit, and there will be plenty of demonstrations throughout. Here we go. Okay, so what is the Garmin GPS receiver? Well, it's an instrument that's manufactured by Garmin, that makes sense, right? Which provides satellite GPS data in a standardized format. And the type of data you can get from this GPS includes latitude, longitude, altitude. It'll tell you what hemisphere you're in, how fast you're going in knots, what your course is, as well as give you very detailed time and date information. So how can this be useful? What type of applications and industries is this applicable for? Well, let's talk about that. So some typical markets you might find this might include mobile equipment, asset management, agriculture, building management, marine. There's a variety of different markets in which GPS makes some sense. In terms of the specific application functions you might use, having the location available to you can help you with applications where you're looking to track assets, or maybe you've got a large piece of rotating machinery, and I mean large, and you're looking to calculate things like its angle of rotation, for instance. And there's a variety of ways you could do that with different, options besides GPS, but that's a function you could perform. And then GPS time is also pretty useful because you're getting, really accurate time delivered via satellite, which means if you have different units distributed over a large geography, they can all be doing things like data logging with a timestamp that is synchronized. That can be pretty valuable as well. Okay, so let's take a look at some of the specifications. Now, specifically today, I'm going to be demonstrating the Garmin GPS Receiver 19X HVS. That particular one is the one we're talking about today. So it's got an IP rating that's pretty rugged, a good wide temperature range. It's got a wide range power supply, so you can power it from 24 volts or 12 volts, depending on your application. It connects using flying leads. That's the specific interface that we're working with today, and it has good positional accuracy. Now, in terms of how it interfaces with the OCS, I've mentioned multiple times before, of course, that it utilizes this NMEA 0183 protocol. And actually, that is a protocol that the Horner OCS does support as a downloadable serial protocol. And when you look at the list of your downloadable serial protocols in Cscape, as you're going through the available serial ports, you'll see it listed as GPS protocol. That's how it's listed. Now, in the case of this specific Garmin receiver, it talks at 38,400 baud. There are some other Garmin receivers that we've used in the past that you could probably find today. Those interface at 4,800 baud. But because this is a newer unit and it provides a lot of data, it just made sense, I'm sure, for them to speed up the communication so they could get more throughput on the data. Now, the data that is received by the OCS is pretty much one way. In other words, the Garmin is just spitting out this GPS data almost on a continuous basis. The Horner OCS is sitting there receiving that data, parsing the data, and mapping it to a block of consecutive registers or into a single variable array that has a length, I believe, of 28 words. Okay, well, instead of believing that it might be 28 words, let's go through the specific receiver data map and see what we've got here. So you can see this is the first half of the data map. We've got our mix of latitude and longitude data here, along with, the real-time clock information, the satellite-based real-time clock. Again, that can be extremely valuable in several applications. So this is, what the data looks like for the first, 14 words of data. And then for the next 14 words of data, we've got a mix of integer and double integer data. So that's why you see fewer parameters here in the second half of this table, because some of it is in double integer type format. Also, some of it has implied decimal points, so you need to kind of pay attention to that as well. Although don't worry, I have provided, available for your download, a demo program that takes care of a lot of the data conversion. Now, from a connection detail standpoint, here is the detailed connection for the Garmin HVS model, all the different flying leads that it has in terms of the colors of the wires, and then specifically which ones need to be connected to power, which ones need to be connected to common, and which ones need to be connected to the Horner OCS serial port, which is MJ1/2. It actually connects to the RS-232 pins on that particular port. Now, as I mentioned just a minute ago, there is a mix of data that you'll find in that data table that is being sent by the GPS. And some of that data has implied decimal points, some of it's integer, some of it's double integer. So there is a reasonable amount of conversion that may need to be required if you're going to be doing any math on the data from the GPS. If all you're going to be doing is displaying it on the screen, it's really extremely simple. There's no special handling that has to be required. But if you actually do want to do some math on some of the data, there may need to be some manipulation done. But as I mentioned also, I've got a program for you that handles that all for you. Okay, well, let's get right to it and let's demonstrate the Garmin GPS connected to a Horner OCS. All right, let's start out on the bench here by taking a look at the demo program that I've created for the Garmin GPS. And it's currently running on a Micro X7, but it could run on literally any Horner controller. Okay, so one thing you may be wondering is, if this is a Garmin GPS or a GPS of any kind, how are you getting data if you are indoors right now? And you're right, I am indoors right now, but the GPS itself comes with a pretty long cable. So there's a 25-foot cable that connects my Micro X7 to the Garmin GPS that's located outdoors. So that's how I have a good signal. All right, so the data we've got here is the data you'd expect. We've got our latitude data, our longitude data, our height above sea level, ground speed, our course, how many satellites we have in view. We've got our time and date over there. So we're getting all of our data. And then I've also got a diagnostic screen where we can make sure we have good communications. Okay, now, there is a bug in the driver that you need to be aware of because it does affect the status register. So we are getting a good fast pull time of the GPS, but one thing you'll notice is that the good response counter is not incrementing. It should be, because we do have good communications going on right now. So there is a bug in that driver as of when we did this taping, so be aware that your good responses aren't counting up. But in my demo program, I did create a GPS OK bit, and I'll show you how I did that so you can monitor when you do lose communications with the GPS. But anyway, that's the demo program that's available to you to download. Wanted to show it to you on the bench before we go through the logic. Let's take a look at our demo program now, starting with the hardware configuration. So we're going to hardware configuration. My demo is written for a Micro OCS X7, but could be run literally on any Horner controller. And our configuration starts under serial ports and config. So under MJ1, that's our RS-232 port, you can see I've selected GPS protocol version 5.02. So that's the protocol that we use to communicate with the Garmin GPS. And we have our normal 3 levels of communications we need to set up. So let's do that quickly here. Okay, under network, for this particular Garmin unit, we have 38400 as our baud. We mentioned that earlier. Okay, everything else is pretty much at the default. Now I have sped up the timeouts to 5 seconds. All right, I don't believe those are the default. Maybe they are. Maybe I didn't actually speed them up, but I'm using a default timeout of 5 seconds for response from the GPS as well as for my reacquire time. Okay, I've got an automatic update on my update scan so that the OCS will be receiving in the data as fast as possible. I have assigned a disable bit variable, you can see here, as well as GPS status. And I mentioned earlier on the bench demo that the good responses double word is not working properly as we do the taping. So we have to come up with an alternative way of verifying we have good communications, and I'll show that to you in a little bit. But anyway, this is the top level of the configuration for the GPS protocol. On the device level, you can still click on it here, but there's nothing to configure. This is a point-to-point RS-232 type connection, so there's nothing you have to configure. Let's go to scan list, and the only thing you have to configure on scan list literally is the length of the data that you want to read back. Okay, and if you want to read all of the data, that's 28 words. And you need to assign a local variable where those 28 words will be stored away. And I've got an integer array that I have created that is 28 words long called GPS DAT. You just leave it as polled read, and you're done with the configuration of the serial port. So that's all there is to it on the configuration side of things. So now automatically, let me go to the data watch here. Automatically, we have data just coming into our GPS DAT array. And I'm on my data watch window. I'm just looking at a few of those 28 words. Remember, it's GPS DAT 0 through GPS DAT 27 is the data we have available to us. I'm just looking at a few of those words. The ones that were a little bit tricky, I've got those on the data watch window. Okay, now what's the ladder logic in there? Well, you don't necessarily have to have any ladder logic, but as I mentioned earlier, the data comes in a mix of integer and double integer. There is some implied decimal points in the data that we're receiving. If all you want to do is just display the data on the screen, you don't have to do anything special. But if you want to create variables for every piece of data that comes in that you can then do math on later, for instance, anything with an implied decimal point, you'd want that to be a floating point variable, for instance, then you're going to want to do a little bit of math to create those variables. So as we go through the logic here, I'm not going to go through all the details, but basically what I've done, let's start with, let's finish with what we end up doing to create a GPS OK indicator so that we know when we're communicating properly. On the logic side, let's start with what we're doing in the logic for breaking out the individual variables from this big bank of 28 words of data coming in from the GPS. So for the latitude data, we're breaking down the individual words into latitude degree, latitude minute, latitude second, and then what hemisphere we're in. Okay, so those are variables available to you for latitude. The same variables are available for longitude. We have taken the 6 words of GPS time and broken them down into 2 smaller arrays, one for date, 3 words long for a date array, one for time, 3 words long for a time array. We have a GPS quality word that comes back. We're just using it to basically set a flag whenever we have no GPS fix. In other words, we don't have a GPS fix in the sky. So when this bit turns on, that'll tell us that. Okay. And then, we've got GPS satellites in view. We've created that variable from the stream of data coming back. Horizontal dilution of precision. Don't ask me specifically what that is. I haven't looked it up, but it is now there available in a variable for you. Your height above sea level, I've created a variable called GPS elevation. That's a real variable because there are definitely implied decimal points in this particular variable. We have geoidal height, all right, which I believe is some sort of compensation for the fact that the Earth really isn't a perfect sphere. And then we have speed over ground, course over ground, and then some non-truncated seconds information for both latitude and longitude. And exactly how this ladder works, you don't really need to know that. I've done all the hard work for you, so all the all the variables are created, and anything that has a decimal point in it has been created as a real variable. Now let's get back to the beginning where I derived this GPS OK bit. Now, if we don't have a good count of messages counting up, how are we doing this? Well, in this case, really what we're doing is when we first power up or on the first scan, we are setting the seconds field. That's the one that should be updating at least every second. We're setting the seconds field that we get back from the GPS to a non-valid value. So we're setting it to 99 because they should be coming in between 0 and 59 seconds, okay? So before we're communicating with the GPS, we've set it to a non-valid value. And then as soon as we start getting good values coming in from the GPS, we'll turn on our GPS OK light. And then if we ever get a scenario where our seconds stop incrementing for longer than, say, 3 seconds, then we know we've lost communications again, and we'll turn off our GPS OK indicator. So that's really all there is to the little bit of data or a little bit of logic that I use to derive a GPS OK bit, which you can then use in your program to tell you when you've lost communications with the GPS for whatever reason. Okay, so that's a look at the demo program available for you to download. Again, I would recommend that if you're going to be using this GPS unit because I did all the heavy lifting for you in terms of creating all these variables based on the GPS data. Okay, that does it for our content for today. There still is some time to sign up for OCS training, so do that today on our website. We'd love to talk to you about your application in person, and one of the ways you can do that is by visiting some of the trade shows that we will be exhibiting at over the 3rd and 4th quarter of this year. And as you can tell from the screen, there's a lot of them, most of them being in the South and the Midwest. The big show coming up, which I'll talk about more in a minute, is WEFTEC. That's the water industry show coming up here at the end of the month. And I'm going to be attending that along with the rest of the Horner team, at least the marketing team and the sales team. We'll have a good presence there, and we'd love to talk to you at WEFTEC. All right, if you'd like to interface with us online, you can do so at hornerautomation.com. You can see this video that's available along with hundreds of others on YouTube, and you can interface with us on LinkedIn, where you'll find a lot of announcements as they happen in real time. Okay, well, I mentioned that WEFTEC is coming up here at the end of the month. So next week, actually, we will be broadcasting from WEFTEC. So we're looking forward to bringing you a very interesting show. Now, we aren't just going to be, in our show that we're going to be broadcasting, we won't just be showing you products that you've already seen. In addition to that, we'll also be showing you some things that we're previewing just for the show. Some particular products that are on their way for the future that you may not have heard of. You almost certainly have not heard of several of these. So if you'd like to check those out in a virtual fashion, because you can't make it to Chicago in person, then join us for our WEFTEC broadcast September 30th at 2 o'clock. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so I'm hoping to see you next week in person at WEFTEC, but if not, join us next week for the broadcast. And until then, let's all get out there and do some good.